Imagine a universe where the rules you thought you knew simply dissolve. A tapestry woven in ways that cannot be undone. In this strange quantum realm, there are knots that can never be untied, loops that can never be broken, and patterns so deeply embedded in the fabric of reality that no force can erase them. These are what we call topological quantum states, mysterious realms where matter behaves like something alive, something that remembers its own shape, something that refuses to be simplified. At first glance, this might sound abstract, even impossible, but these states are real. Take electrons, for example. We usually picture them as solitary particles, zipping around on their own, but under certain extreme conditions, they begin to collaborate. They form collective states where the whole is far greater than the sum of its parts. When you confine electrons to ultra-thin, two-dimensional layers, or subject them to incredibly powerful magnetic fields, they stop behaving like individuals. One of the most astonishing examples of this is the topological insulator. The very existence of these edge states shatters our classical understanding of materials. Then there is the fractional quantum Hall effect, a phenomenon so bizarre it borders on science fiction. Particles that are, for all intents and purposes, not supposed to exist. In this state, the individual electron loses its meaning. They aren't fundamental particles like electrons, but manifestations of the collective order. This whole field of study forces us to rethink reality itself. It suggests that the universe isn't just a collection of particles interacting through forces. It's a web of patterns, of information, of persistent order that remains resilient even in the face of random disruption. These knots in the quantum fabric preserve themselves, impervious to time and disturbance, hinting at a cosmos that is far stranger and more beautiful than we can perceive with our everyday senses. Imagine a realm where destruction is impossible without total annihilation, where the very shape of existence protects itself, and where the rules of our classical world are rendered meaningless. Today's quantum computers are incredibly powerful but also incredibly fragile. The slightest disturbance, what physicists call decoherence, can introduce errors and ruin a calculation. But what if you could build a quantum computer using topological qubits? These topological qubits would store information not in the state of a single fragile particle, but in the unbreakable braids of quasi-particles. Each braid, each twist in their dance, would be a safeguard against failure. Information would be protected by the fundamental geometry of the system itself, making the computation almost completely error-free. This would be a monumental leap forward, a testament to the inherent stability encoded in nature's deepest designs. The potential is staggering. If these ideas are mastered, we could enter an era where computation, communication, and material science are utterly transformed by the geometry of quantum reality. Imagine unhackable communication networks, or new materials with properties we can currently only dream of, all built on these principles of topological protection. And yet, beyond the technology, there is something almost poetic about topological quantum states. They are invisible, intangible, yet their effects are undeniable. They exist in a fascinating space between pure mathematics and experimental physics, where elegant equations describe possibilities that nature, it turns out, has already realized. They remind us that reality is not a flat, empty stage for particles to play on. It's a living network, full of intricate patterns, memory, and an astonishing resilience. These are worlds that cannot be untangled, threads of existence woven so tightly that even our most sophisticated tools can barely begin to probe them. In the end, the study of topological quantum states is more than just science. It's a journey into the heart of the universe's secret architecture. It's a glimpse at the hidden rules that govern not just matter, but possibility itself. In trying to understand these quantum knots, we begin to understand a universe that is patient, precise, and unimaginably profound. It challenges us to think differently, to see beyond the surface of things, and to marvel at the hidden order that persists, even in places where chaos seems to reign supreme. Have you ever felt like you're glimpsing a hidden reality, a layer of existence just beneath the surface of what we see? Well, get ready, because we're about to dive into a world that feels more like magic than science. The realm of topological quantum materials. Imagine tiny particles, electrons, but not as you know them. Instead of scattering randomly like billiard balls, these electrons are braided together in intricate patterns. They move in paths dictated not just by forces, but by their collective history, as if they carry a memory of every twist, every turn, every entanglement they've ever experienced. It's like they're dancing to a silent, cosmic choreography. The result is something extraordinary. The system as a whole becomes more than just a collection of its parts. It transforms into a single resilient entity. The information isn't stored in individual particles anymore. It's woven into the very geometry, the very shape of the quantum field itself. It's so robust, so resistant to errors, that scientists have started calling these topological states nature's perfect error-correcting system. The design is so elegant, it feels almost intentional, as if it were designed by an intelligence far beyond our own. But to truly grasp this, we need more than just equations and data. We need imagination. Picture a world where particles are like tiny dancers, gracefully tracing invisible braids through a four-dimensional space. It's a concept that's easy to lose if you do unhold it just right in your mind. One wrong turn in your visualization, and the whole beautiful idea can just slip away. Yet, hidden within this abstract dance lies the key to some of the most powerful technologies humanity has ever dreamed of. Think about quantum computers. We hear about them all the time, but building a stable one is incredibly difficult. Most quantum systems are fragile, easily disturbed by the slightest noise. But a quantum computer built on topological principles, that's a different story. These topological quantum computers would encode information in a way that is intrinsically protected. The braids themselves would be the qubits, and to destroy the information, you wouldn't just need to disturb a single particle. You'd have to break the entire braid. A feat that is incredibly difficult. It would be like having a shield woven directly into the fabric of reality, protecting the fragile quantum information from the chaotic outside world. This could allow us to solve problems that are currently impossible, problems that would take a classical computer longer than the entire age of the universe to crack. And the wonders don't stop there. Let's talk about topologicals. Inside these incredible materials, strange quasi-particles emerge, particles that are their own antiparticles. They're called Majorana fermions. These Majoranas can also form braids, creating a system that preserves information perfectly, without any loss or decoherence. These aren't just theoretical curiosities, they are the potential foundation for unbreakable quantum memory. We're talking about the hardware for machines that could think in the native language of the universe itself. Every single braid, every knot, every entanglement in these materials becomes a living record of possibility. It's a testament to the unyielding order that lies hidden beneath the apparent chaos of the quantum world. When you start thinking about this, the implications stretch far beyond just building better computers. They become philosophical. If reality can preserve itself in patterns that cannot be untangled, what does that say about the universe at large? Could there be cosmic analogues to these quantum knots? Are there massive structures of space-time or matter that maintain their form over eons, completely impervious to entropy and decay? Could the universe itself be a vast topological network, a cosmic tapestry where the patterns of existence are woven into a resilient, unbreakable fabric? The more we explore this field, the more it feels like what we perceive as disorder and chaos might just be surface noise, hiding a profound and unbreakable structure underneath. Topological quantum states are forcing us to completely reconsider our fundamental understanding of reality. They challenge our ideas of causality, of locality, and of the very nature of information. In these systems, the properties of the whole cannot be reduced to the properties of its individual parts. The history of the system, the connections between the particles, the story of their braiding it, all matters. There's something both unsettling and mesmerizing about this idea. The thought that some aspects of reality are fundamentally untouchable, that they're inaccessible to our direct manipulation. It's as if the universe contains secret rooms, hidden corridors, and locked doors that we can only glimpse through the faint shadows cast by mathematics and cutting-edge experiments. And those experiments are happening right now, in labs all around the world. Physicists are cooling materials to temperatures near absolute zero, just a fraction of a degree above the coldest possible temperature. They're remanipulating individual electrons with incredibly precise magnetic fields and measuring phenomena that completely defy our classical intuition. Every new discovery peels back another layer, revealing a deeper part of this quantum knotwork. We're mapping patterns that can't be untangled, but that can be observed, understood, and perhaps one day, harnessed for the benefit of all humanity. The sheer elegance of these states, their stubborn refusal to be disturbed, and their mind-boggling potential make this one of the most exciting frontiers in all of physics today. It's a field where discovery feels like it's just around the corner, and as we step back, away from the complex equations, the lab benches, and the diagrams of braids and edge states, a larger truth begins to emerge. The universe is stranger, more intricate, and far more beautiful than we ever could have imagined. Topological quantum states aren't just a scientific curiosity. They are a window into the very architecture of existence itself. They remind us that reality is layered, that beneath the chaotic, noisy surface of the world we experience every day, there lies a resilient, hidden structure, a web of threads, of connections, that cannot be untangled, knots that preserve the very memory of existence. And the more we learn to see these threads, the more we understand our true place within this magnificent cosmic tapestry. Thanks for joining me on this journey into the quantum unknown. If you found this as fascinating as I do, have you ever felt like there's a hidden layer to reality, a secret language the universe speaks just beyond our perception? Well, it turns out, there is, and it's written in the strangest, most beautiful script imaginable, knots, braids, and twists at the very heart of matter. This is the world of topological quantum states, and it's about to change everything you thought you knew about the universe. The deeper we delve into the quantum realm, the more it feels alive, as if it has its own hidden intelligence. It whispers secrets through patterns we're only now beginning to decipher. Each experiment, every observation, every mathematical breakthrough is like lifting a tiny corner of reality's veil. We're peering into a world that defies the limits of our imagination, where the rules of our everyday experience simply break down. These topological quantum states aren't just strange phenomena for physicists to study. They are a profound statement from the universe itself. They tell us that perfect order can persist even where chaos seems to rule. They show us that structure can survive even the most destructive forces. They prove that reality is far more intricate and resilient than our senses could ever lead us to believe. And in this strange, untouchable order, there lies a lesson for all of us. Think about it. Just as these quantum knots cannot be easily unraveled by random disturbances, perhaps there are fundamental patterns in our own lives' connections, choices, relationships that endure beyond the apparent chaos of daily existence. The universe, in its smallest components, teaches us resilience. It teaches us stability, and it reveals the profound beauty of structures that can withstand the relentless passage of time, the pressures of disturbance, and the randomness of existence itself. In the tiniest twists of an electron's path, in the unyielding braids of quantum matter, we glimpse a mirror of persistence. We see a reflection of the infinite complexity that underpins everything we see, touch, and feel. So tonight, when you look up at the vastness of the stars, remember this: an equally vast and ordered cosmos exists in the unseen quantum world right beneath our feet, a hidden tapestry of reality that refuses to be undone, a world that cannot be untangled. And maybe, just maybe, in trying to understand these hidden knots, we also come a little closer to understanding ourselves. We start to see the threads, the patterns, and the deep connections that shape our own existence. This journey into the heart of topological quantum states is so much more than just science. It's a journey into pure wonder. It's a voyage into the very essence of reality. A place where mathematics, physics, and human imagination collide to reveal the deepest secrets of existence. As we stand at the edge of this new quantum frontier, one thing becomes crystal clear: the universe is far stranger, far more resilient, and far more beautiful than we ever dared to imagine. For those of you who seek to understand, who wish to explore the unseen, the impossible, and the eternal, the story doesn't end here. It's only just beginning. The knots of reality await us, the braids of countless quantum worlds beckon, and the mysteries of existence stretch far beyond what we can touch, beyond what we can see, and perhaps even beyond what we can currently comprehend. In every new discovery, in every unraveling of the unknown, we are reminded of the infinite possibilities that lie just beyond our grasp. Welcome to a world where reality cannot be undone, where the very fabric of existence twists and turns in patterns of unbreakable, breathtaking beauty. Thanks for joining us on this journey. If you want to explore more mysteries of the cosmos, from the impossibly strange to the beautifully quantum, make sure to subscribe and hit that notification bell. We've got so much more to discover together. See you in the next one.